Okay, our sixth lecture on Chapter 8, which is focused on water, is going to start our discussion of acids and bases. This is an important concept when we are discussing water. Previously, when we talked about air pollutants, we said that one of the issues of some of the pollutants is they can increase the acid in rain, which can cause environmental damage. So we need to understand what happens when certain compounds, specifically acids and bases, are added to water. So let's first start with the definition of an acid. If you were to ask someone today what is an acid, they would go into a discussion about the hydrogen ion. But before this was easily measured and quantified, people characterize something as an acid based on some of their properties or characteristics. That first characteristic being a sour taste. So if you think of something like lemon juice, it's a sour, that is an acid. Most acids, but not all, are corrosive. So that was another characteristic that is associated with acids. And one of the first tests that was developed to look at compounds that were either acidic or basic was the litmus test. Litmus test is a dye that is derived from vegetables. This is the color of the litmus dye. This is on litmus paper before it is in contact with a solution. If you stick that into a solution that's acidic, it turns red. If it's basic, it turns blue. Well, we know a lot more about acids now, and we know that an acid is a substance that releases a hydrogen ion in aqueous solution. So what is the hydrogen ion? The simple answer to that is H+. But let's think about the hydrogen atom on the periodic table. The hydrogen atom has an atomic mass of 1, which tells us that it has 1 proton, no neutrons, and when it is in its atomic state, not as an ion, it has an electron. When we look at the ion, H+, this means it has lost 1 electron. Now it has a +1 charge. So if we look at the composition of the hydrogen ion, we still have that 1 proton, no neutrons, and no electrons. Since this ion is basically just a lone proton, people will often refer to the H+, the hydrogen ion, as a proton. So how do these form in solutions? What happens? Here's an example of hydrochloric acid, which is a gas. When you bubble that gas through water, that dissociates H+ and Cl-. So you form that hydrogen ion on that proton in water. This reaction can occur with gases, liquids, and solids. Again, once we dissolve that in water, we are forming an aqueous compound. So the reaction I just showed the formation of the hydrogen ion. This is very common when we talk about acids and bases, but this is actually not a true reflection of what is happening in water. So when you add the hydrogen ion to water, it is actually very reactive and forms a hydronium ion, which is that addition of the H+ to the water molecule. This is a Lewis dot structure of the hydronium ion. So we have our original water molecule with that extra hydrogen added. Again, this is known as a hydronium ion, H3O+. When we write reactions, we often will just use the H+ for simplicity, but it's important to understand that there is not just H+ floating around in water. It exists as this hydronium ion. So that finishes our discussion about acids and the characterization of acids. And now we want to look at the flip side, or the reverse, bases. So often when we talk about acids, we talk about acid-base chemistry. You will see in the next lecture how these are closely tied together. And as we did with acids, we want to look at some of the properties of bases. So a base is a compound that produces the hydroxide ion, OH, in water. Make sure you know that hydroxide ion is OH. Some of the characteristics is that they're bitter tasting. slippery when you dissolve them in water. So if you've ever gotten bleach on your hands and that slippery feeling that is left behind, that is because bleach is a base. We said that acids turn litmus paper red, bases turn litmus paper blue. Again, that was one of the initial ways that you could test if something was an acid and base. We have a lot more tools now to look at the pH of a solution. Here is a reaction showing a base in water, sodium hydroxide. Again, this is a solid that we're dealing with. Bases can be solid, liquids, or gases. That sodium hydroxide, when added to water, dissociates to form the sodium ion and the hydroxide ion. Again, this is a base because that hydroxide ion is being formed. Let's look at another example of a base. This time we're going to look at calcium hydroxide. Again, when you add calcium hydroxide to water, you form your calcium ion and your hydroxide ion, OH. One of the difference between calcium hydroxide and sodium hydroxide is when you add the calcium hydroxide to water, you are forming 2 moles of hydroxide ion. So this is something that you will want to remember when we're looking at both acids and bases. The stoichiometry, or the number of moles that are produced when you add it to water. And this will be important when we start looking at the concentration of acids and bases. So if you add 1 molecule of sodium hydroxide to water and 1 mole of calcium hydroxide to water, the calcium hydroxide is going to produce a solution that has a higher concentration of that hydroxide ion, because for every 1 molecule of calcium hydroxide, you form 2 molecules of hydroxide. Something else I want to point out is that you can have a base that does not have OH in its formula. The prime example of this, and really the only example we'll encounter in this class, is ammonia. When you add ammonia to water, you initially form ammonium hydroxide. That ammonium hydroxide then dissociates to the ammonium ion and hydroxide. So while ammonia does not have OH in its formula, it still produces that OH minus in solution, which means it is a base. The last thing I want to talk about in this lecture is neutralization reactions. A neutralization reaction happens when you add an acid and a base. If you add an acid such as hydrochloric acid to a base such as sodium hydroxide, you add them in equal amounts, you end up forming sodium chloride and water. So if you remember, the acid produces H plus in water, the sodium hydroxide produces OH minus. Those combine to form water. So if you mix an acid and base together, you end up with water and a salt. So this is a neutral compound, meaning you don't have excess acid or base.